Hello student, welcome to my YouTube channel. My name is Manoj Sharma. Today we will see whole number. This is your second lecture. In previous lecture we have studied about the whole number and what is the properties of whole number. Now today we will see operation on the whole number. So let's start. So we will see operation on whole number. Operation on whole numbers. Okay, from this word operation belongs to, there are four operations: addition, subtraction, multiplication, and the last one is division. So in this we will deal with four operations: addition, subtraction, multiplication and division. What is the effect, what are the properties of these four functions in this whole number? Okay, so we will understand one by one. So first one, in the array of the operations addition, subtraction, multiplication and division, first of all we will deal with addition. So properties of addition. Okay, properties of addition we see. First one is closure property. Second one is commutative property. And the third one is associative property. So properties of addition, in this section we will see the first property is closure property, second is commutative property and third is associative property. We will discuss about these properties one by one. So first of all we will see closure property of addition. Closure property of addition. So now what is the closure property of addition? If we have two whole number like A and B, we have two whole number A and B. So sum of two whole numbers always be the whole number. Sum of two whole number means A plus B. If A and B are the whole numbers, then sum of two whole number is always the whole number. For example, 5 is a whole number and 3 is a whole number. If we add this, we will get 8. 5 plus 3 is equals to 8. 5 is whole number, 3 is whole number, then 8 is also a whole number. 6 plus 7, 6 is whole number, 7 is whole number, then result is also a whole number. 8 plus 5, 8 is whole number, 5 is whole number, then 8 plus 5 is equals to 13. 13 is also a whole number. So what is the closure property? States that sum of two whole number always be the whole number. Sum of two whole number always be the whole number. 5 plus 3 is equals to 8, 6 plus 7 is equals to 13, 8 plus 5 is equals to 13. Now we will see the second property of addition. Second property is commutative. commutative property of addition. So what is that? If we have two whole number a and b, if we have two whole number a and b, and sum of a and b is equals to a plus b. Okay, now we will change the order b and a. Okay, this is b and this is a. Sum of this order is b plus a plus b and b plus a. So according to commutative property of addition, a plus b is equal to b plus a. Whatever result of this a plus b, the same result if we change the order of this number, this whole numbers, then we will get the same answer. Likewise, example, 5 plus 6 always be the same as 6 plus 5. In this we have first whole number is 5 and this one is second whole number. First one and this one is second one. And in this one it will be first one and this one will be second one. Okay, first plus second, first plus second. In this example, here is first whole number is 5 and second whole number is 6. In this one, first whole number is 6 and second whole number is 5. We have just changed the order. 5 plus 6, 6 plus 5, but they both have the same result. 6 plus 5 is equal to 11 and 6 plus 5 is equal to 11. So this is the property of addition, commutative property of addition. If we change the order of the whole number, there will be no change in their result. We have two whole number a and b, and sum of a and b, a plus b, and we have two whole number b and a. We just change the order, b plus a. This is the sum. So likewise, this is the example, 5 plus 6 is equal to 6 plus 5. See, we just change the order, not the digits. We just change the order, not the whole numbers. Okay. One more example. 11 plus 12 always be equal to the 12 plus 11. Same answer. 7 plus 3 equals to 3 plus 10. This is the commutative property. 3 plus 7. 6 plus 9 is equal to 9 plus 6. 2 plus 5 is equal to 5 plus 2. These all are the, we just change the order of the whole numbers, but it will not change the result of the whole numbers. So sum of all these whole number always be the equal. This one equal, this one equal, this one equal. 11 plus 12 will be 23 and 12 plus 11 also be 23. 7 plus 3 10, 9 plus 6 15 and 5 plus 2 7. These all are, whether we will take 11 plus 12 or 12 plus 11, it will always be the 23. This is the commutative property. There is no effect on the changing of the order of whole numbers. Sum always be the same in both the manner, a plus b and b plus a. Okay. Now we will see next property of addition. Associative property. What is the associative property of addition? We have three whole number, a, b and c, and same way a, b and c. Okay. What is the associative property? If see, whatever the result of this two whole number, sum of these two whole number is added with a, b plus c will be added to a, and one second. See, this is the associative. We have the same whole number, a, b and c are the whole numbers, and in this one the sum of b plus c is added to a, and this one, in this one, a plus the sum of a plus b will be added to c. Okay, in both the condition we got the equal values. Okay, in both the condition we get the equal values. See example 5, 6, 7, and here is 5, 6, 7. Okay, in both the condition, see, according to the BODMAS rule, first of all we will solve this bracket according to the BODMAS, BODMAS, bracket of divide, multiply, addition and subtraction. According to this BODMAS rule, first of all we will solve this bracket. So 6 plus 7 is 13, as it is 5. 13 plus 5 is equals to 18. 13 plus 5 is equals to 18. Now we will see here 6 plus 5, 11 plus 7. First of all, according to BODMAS, we will solve this bracket. So 5 plus 6, 11. 11 plus 7 is equals to 18. See, we just get the same result. We just get the same result. This is the proof of associative property of addition. Okay, means we just associate any whole number with a group of whole number. In the same way, if we just change the order, we will get the same result. Likewise, we have already explained in example 5, 6 and 7 are the whole number. 6 plus 7, group of 6 and 7 is added to the 5. It will give you 18, and 5, a group of 5 and 6 will be added to 7. It will also give you 18. We just change the order, we just change the grouping, but not the digits. 5, 6, 7 is here, 5, 6, 7 is here, but grouping is 6, 7, and here is 5 and 6. But you are observing that there is no change in the result. So this is the associative property of addition. Okay, one more example. We will see through one more example. 3, 2, 5 and 3, 2, 5. See, okay, now 3 plus 7 is equal to 10, and here is 3 plus 2, 5 plus 5 is equal to 10. See, we have the same result. There is no change in the changing of the order, in the changing of the group. Okay, so now these are the properties of addition. First one is closure property, second one is commutative property, and third one is associative property of addition. Now we will see the in a same way properties of subtraction. See, we just change here some words. Properties of subtraction. Properties of subtraction, and here is closure properties of subtraction. Okay. Same way, first properties is closure properties, second property is commutative, and third one is associative. Now the first one is closure property of subtraction. If we have A and B, if we have A and B, two whole number, and here is, see, A and B, what is the closure property of subtraction? A and B, A minus B. If we subtract these two whole number, then result of this two whole number always be the whole number. So subtraction of two whole number always be the whole number. Means example 5, 3. 5 is whole number, 3 is whole number, 5 minus 3 is equals to 2. 2 is also a whole number. 3 minus 2 is equals to 1. 6 minus 5 is equals to 1. See, but here is you are observing one condition. A is always greater than B. A is always greater than B. Closure property of subtraction always apply on one condition. First term always be greater than second. First term is always be greater than second. First term is always be greater than second. First term is always be greater than second. Then we will get the whole number as a result. So subtraction of two whole number always be the whole number only on only one condition, when first term always be greater than second one. This is the closure property of subtraction. One most important thing I would like to remind you that do not skip the video and watch the full video carefully, otherwise you will miss all these properties, okay, and you will get confused. Okay, now the second property is commutative. Now we will see associative property of subtraction. What is the associative property of subtraction? If we have three whole number A, B and C, A, B and C, so group of two whole number in subtraction, group of two whole number will be associated with the third one. Group of two whole number will be associated with the third one, but it will not be the same as another group of whole number will be associated with third number. Means property subtraction is not commutative. Subtraction is not commutative. How we will be prove that? See, we have three whole number 8, 7 and 6. 8, 7 and 6, and what will be the result? See, if we have grouped this 8, 7 with 6 and here is 7 and 6 with 8, so what will be the result of that? 8 minus 7 is 1. According to the BODMAS rule, we will first of all we will solve this bracket. 1 minus 6 is equals to minus 5, and 8 minus 7 minus 6. 7 minus 6 will be 1, and 8 minus 1 is equals to 7. See, we are getting different result. That means subtraction is not associative. Subtraction is not associative. Now we will go through another one example. That is 3, 2, 1, 3, 2, 1. Okay. See, 3 minus 2 minus 1 and 3 minus 2 minus 1. See, 3 minus 2 minus 1 is 1 and 3 minus 1 is equals to 2. 3 minus 2 is 1. 1 minus 1 is equals to 0. We are getting the different result because subtraction is not associative. Okay. Now we will see commutative property. See, commutative property of subtraction. See, if we have two whole number and subtraction of whole number, it will not be the same as B minus A. Okay. So what we have, if we change the order of the whole numbers, then there will be different result of subtraction. Means subtraction is not commutative. Subtraction is not commutative. Okay. For example, 8 minus 7 and 7 minus 8. We have two whole number. In example we are seeing this, we have two whole number 8 and 7 and 7 and 8. We just change the order. 8 minus 7 will become 1 and 7 minus 8 will become minus 1. This one is positive value and this one is negative value. So commutative property of subtraction, subtraction is not commutative. We will understand one more example. One more example is 9 and 6. We have two whole number and here is we just change the order. 6 and 9, subtraction of 9 and 6, 9 minus 6, and this one is 6 minus 9. From here we will get 3 and from here we will get minus 3. This one is positive value and this one is negative value. That means subtraction is not commutative. Now we will see the difference of both the properties. Say addition and subtraction. Okay, on the basis of closure property, commutative and associative. Okay, now on the basis of closure property, addition will follow the closure property, but subtraction will not follow the closure property. Commutative, addition will follow the commutative property, but subtraction will not follow the commutative property. And associative, addition is associative but subtraction is not associative. Okay, and closure property will be followed by the addition but not the subtraction. Addition is commutative but subtraction is not commutative, and addition is associative but subtraction is not associative. So these are the properties of addition and subtraction. So do not skip the video and don't forget to subscribe my channel. Okay, and if you have any problem then let me know in the comment section. And regarding to this lecture, I will give you some question which have those download links in the description box. Thanks for watching.